What if the most expensive tank ever built could not survive something you could order online? Ole sits hunched over a battered monitor, eyes fixed on a grainy, black and white feed. Across a scarred field outside Avdiivka, a Russian T-80 BVM tank idles behind a berm, $4 million of steel, sensors, and armor. In Ole's hands, a plastic controller, patched together from hobby shop parts and scavenged wires, guides a homemade first-person view drone. The build cost was about $460. The drone rides low, weaving past trees and shell craters, its camera relaying every bump and breathless second. As the tank's crew scans the horizon, the drone closes in, engine whirring, crosshairs steady on the engine deck. With a final twitch of the thumbstick, Ole sends the drone diving. The explosion rips through the turret, scattering debris across the mud. The tank is finished, dead in seconds. No airstrike, no missile, just a garage-built aircraft and a few $100s worth of electronics. On the front line, this isn't rare, it's routine. Each strike like this forces a question. If one $500 drone can erase a multi-million-dollar tank, how many more tanks can survive the next wave? Rows of soldering irons flicker in basements and converted warehouses from Lviv to Kharkiv. What began as a handful of hobbyists has exploded into an industrial engine. More than 200 registered drone manufacturers now operate across Ukraine, backed by a network of volunteer workshops and commercial startups. In early 2024, the Ministry of Defense formalized this surge, launching a procurement office that signs contracts with dozens of domestic firms. The numbers are staggering. 104.2 billion Ukrainian hryvnia, about $2.5 billion, has been committed to drone production for 2024 and 2025. Each month, brigades receive direct funding, with $59 million allocated for frontline units to source their own drones. The result is a hybrid supply chain, where state contracts, private investment, and grassroots assembly lines feed the front with a constant flow of first-person view kamikaze drones, loitering munitions, and reconnaissance platforms. At any given moment, up to 200,000 drones roll off these lines each month, flooding the battlefield with low-cost aircraft. The question now is not whether a tank can survive a drone strike, but whether any armored column can survive this scale of production. Russian tank losses have reached a scale not seen since World War II. Open-source intelligence analysts, using satellite images and geolocated wrecks, count more than 10,300 Russian tanks destroyed or abandoned across Ukraine since 2022. Add in infantry fighting vehicles and armored personnel carriers, and the tally climbs past 13,000. These aren't just numbers. They represent entire armored brigades erased, factories worth of steel and electronics turned to scrap. The majority of these losses, by Ukrainian and NATO estimates, now come from first-person view drones, small, cheap, and nearly impossible to stop in numbers. Each month, open-source intelligence groups update their maps, painting new swaths of the front with icons marking burnt-out hulls. The result is a tank graveyard stretching from Kharkiv to Kherson, visible on every satellite pass. For Russian industry, these losses mean years of production wiped out in months. For commanders, it means armored assaults are no longer a guarantee of breakthrough, but a gamble with little promise of survival. The question pressing on every headquarters is this: how do you advance when every move might end in fire from above? Tank crews now face a battlefield where every movement could be their last. Reports from the Donbass describe crews refusing to cross open ground, even when ordered, after watching columns targeted by first-person view drones. The traditional playbook of advance, fire, recover has been rewritten. Recovery teams, once able to reach a disabled tank in half an hour, now need up to 90 minutes. Each minute spent exposed means more time under drone surveillance and more risk of a sudden strike. Commanders talk about the new friction. A single immobilized tank can stall an entire assault, because no one wants to be the next icon on the drone operator's feed. Field notes from Ukrainian units record crews abandoning vehicles at the first sign of drone activity, leaving behind millions in hardware to save their lives. The result is a front line where tanks cluster in tree lines or behind ruined buildings, waiting for darkness or a rare window of cover. With every hour, the pressure mounts. If armor cannot move or be recovered safely, what options remain for breaking through? Russian engineers rolled out a new class of weapon in the spring of 2024, fiber optic guided drones, each trailing a cable up to 5 kilometers long. The cable, no thicker than a fishing line, links the drone directly to its operator, bypassing the electronic warfare jammers that had been Ukraine's main defense. These drones carry 2-kilogram warheads and cruise at 120 kilometers per hour, delivering high-definition video feeds immune to radio disruption. Ukrainian electronic warfare crews, who once relied on broadband jamming to crash incoming drones, found their tools suddenly ineffective. Early after-action reports from the Kursk sector logged a 30% strike success rate for Russian fiber-optic drones in the first 48 hours of deployment. But adaptation came quickly. Ukrainian teams began targeting the physical tethers with small arms and kinetic nets, and cyber units worked to inject false commands into the drone's control protocols. Within days, the Russian hit rate fell to just 12%. Still, the innovation forced a new arms race. Every breakthrough on one side triggered a counter on the other. As Western tanks rolled into the theater, the question became whether these platforms, built for a different era, could survive in a battlefield where every vulnerability is probed by a $500 drone or a 5-kilometer wire. Western tanks, long considered the gold standard of armored warfare, now face a new kind of threat that no amount of steel can shrug off. In the Kherson sector, a German-made Leopard 2A6 was left stranded after a 1-kilogram drone warhead detonated near its turret, jamming the main gun in place. The crew, trained for high-intensity combat, found themselves powerless as the turret refused to budge, a $1 million machine sidelined by a payload that cost less than a night's fuel. Across the front, similar scenes repeat. M1 Abrams and Challenger 2s immobilized by drone strikes that target weak spots or simply clip a track. With each incident, the logistical strain grows, spare parts run short. Crews begin cannibalizing disabled tanks to keep others running, stripping one Leopard to fix another. Recovery teams, once able to operate under the cover of armor, now risk their lives every time a drone buzzes overhead. The question echoing through Western command posts is no longer whether their tanks can survive, but whether their doctrine can survive a battlefield where every movement is watched and every vulnerability is exposed by a $500 drone. If the old playbook cannot protect the best protected vehicles on Earth, what comes next? Inside the Pentagon, spreadsheets and satellite feeds now drive a new kind of urgency. In 2024, the U.S. Army launched the Rapid Drone Countermeasure Program, RDCM, committing $1.2 billion to technologies that barely existed on procurement lists a year before. RDCM isn't just a funding line, it's a signal. The Army's latest battalion structure blueprint, released in late 2024, carves out entire drone companies, units equipped with loitering munitions, first-person view strike drones, and mobile electronic warfare vehicles. Each company fields around 30 attack drones, 10 loitering munitions, and a jamming suite capable of blanketing 5 kilometers of airspace. The 101st Airborne and the 10th Mountain Divisions have already begun integrating these drone companies, pairing infantry with pilots who train on both commercial and custom-built platforms. For the first time, brigade-level exercises treat drone swarms as a core maneuver element, not an add-on. The Pentagon's budget documents now list drones and counter-drone systems alongside tanks and artillery. The shift is clear in the numbers: $1.2 billion for drone countermeasures, with more to follow. The real question is whether this institutional pivot can keep pace with the speed of battlefield innovation now radiating out from Ukraine. In April 2024, Taiwanese officers gathered in a coastal training ground, their screens filled with the same flickering first-person view feeds that have become routine in Ukraine. The exercise, named Sky Guardian, drilled crews on swarm tactics and electronic warfare, echoing methods learned from Ukrainian drone workshops. Instructors walked teams through assembly lines built from civilian parts, emphasizing speed and improvisation over expensive procurement. This is no isolated experiment. Across NATO, drone warfare workshops now feature Ukrainian pilots teaching British, Polish, and Danish units how to build, fly, and coordinate mass attacks with off-the-shelf hardware. Defense planners in Georgia and the Baltic states have begun field testing first-person view swarms, adapting Ukrainian blueprints to their own terrain and threats. Chatham House analysts now describe Ukraine's model as a playbook for any nation facing a stronger adversary to saturate the battlefield with cheap, scalable drones to offset conventional firepower. As Taiwan accelerates its own drone training programs and NATO officers study Ukrainian procurement and production, a new question hangs in the air. If the world is copying Ukraine's drone revolution, what will the next arms race look like? Today, a $500 drone can neutralize a $10 million tank. As Ukraine's assembly lines scale and the US Army doctrine shifts, the balance of power tilts toward the cheapest weapons. The future of warfare is not armored, it is networked, autonomous, and relentless. The age of invulnerable machines is over,